Hello everyone, welcome back to the channel. Today we are diving into a groundbreaking revelation that has taken the world by storm as the United States Air Force unveils a new hydrogen jet engine that many experts believe could completely transform aviation, military strategy, and global energy competition. This development has stirred conversations across scientific communities, political circles, and defense analysts because a breakthrough of this scale has not been seen in decades. The announcement alone has sent shockwaves through major powers and triggered fresh debates about the future of sustainable air power. The idea of a hydrogen-powered jet engine isn't entirely new. But what makes this revelation so astonishing is the claim that the Air Force has finally achieved what many engineers have long considered nearly impossible. Hydrogen is the universe's most abundant element, but using it efficiently, safely, and at scale in high-performance aircraft has been one of aviation's greatest challenges. Now the Air Force is suggesting they've cracked the code, and if that is true, everything from fuel logistics to aircraft design to global air dominance could be rewritten almost overnight. One of the first things experts are talking about is the engine's reported efficiency. According to early technical leaks and statements made by officials, this engine is said to produce significantly more thrust per unit of fuel compared to conventional jet engines. That means an aircraft equipped with this technology could potentially fly longer distances, consume far fewer resources, and operate at higher performance levels without relying on traditional fossil fuels. This single advantage alone has implications for strategic air operations, long-range missions, and even civilian aviation. Another major factor that has captivated public attention is the environmental dimension. The world has been under immense pressure to reduce carbon emissions, especially from industries that contribute heavily to pollution. Aviation is one of those industries responsible for a measurable portion of global emissions. A fully functional hydrogen-powered jet engine that emits only water vapor could mark a historical turning point. It could reduce the environmental footprint of both military and commercial flight in ways that were previously unimaginable. For decades, experts have said we need a miracle to clean up global aviation. Today, many are asking if that miracle has finally arrived, but the Air Force's move isn't just about cleaner skies or more efficient fuel. There is a profound strategic layer to all of this. The country that controls advanced hydrogen propulsion technology could secure an enormous advantage on the global stage. Hydrogen can be produced domestically, meaning less reliance on foreign oil and significantly improved energy independence. In times of conflict, supply chains are just as important as firepower. If the U.S. military can operate aircraft with an energy source that is both abundant and locally produced, it changes the entire calculus of wartime logistics. This technology could also unlock new aircraft designs. Traditional jet engines come with numerous engineering constraints, from the need to handle high temperatures to maintaining efficient combustion of fossil-based fuels. Hydrogen burns differently, allowing new configurations, lighter structures, and perhaps even aircraft shapes we haven't seen before. Engineers could design jets that fly higher, faster, and more quietly. There is growing speculation that this engine could pave the way for next-generation stealth aircraft, long-endurance drones, and even reusable vehicles capable of near-space flight. What has really intensified global reactions is how sudden this announcement feels. Only a few months ago, most predictions suggested hydrogen propulsion was still decades away from being viable in military aviation. Now the Air Force is claiming successful tests, working prototypes, and potential integration into future platforms. Other nations, especially those competing militarily or technologically with the United States, are undoubtedly scrambling to understand how far this development has progressed and what it means for their own defense capabilities. The geopolitical implications are enormous. If the technology proves scalable, it could shift power dynamics between nations heavily dependent on oil production and those leading in renewable energy and advanced engineering. Countries with massive fossil fuel economies might face new economic pressures, while nations investing in hydrogen infrastructure may suddenly find themselves ahead of the curve, with the U.S. stepping forward with this revelation. Rival powers may feel threatened or pushed into accelerating their own research efforts. One of the biggest questions surrounding this breakthrough is safety. Hydrogen is powerful, but also volatile. Its history in aviation has been marked by concerns about storage, stability, and the risks of catastrophic failure. The Air Force claims it has developed a new containment and cooling system that makes hydrogen storage far safer than it has ever been before. This is a bold claim, and the scientific community is waiting for more details. If the Air Force truly has a stable, lightweight, and durable method for storing hydrogen inside high-speed aircraft, it would be one of the most significant engineering achievements in modern aerospace history. Many analysts are wondering how soon this technology could be deployed. Some early reports suggest that testing has been ongoing for several years under high secrecy. If that is true, then the first operational aircraft using this engine may already be nearing completion. Some even speculate that the Air Force's future bomber programs or advanced drone fleets could incorporate this propulsion system. On the commercial side, major aviation companies are closely monitoring the situation. If the Air Force has solved the fundamental challenges of hydrogen propulsion, civilian industries would be eager to adopt the technology to reduce costs and emissions. There is also the question of cost. Traditional jet fuel is expensive but widely available with existing infrastructure. Hydrogen, on the other hand, requires new facilities, new pipelines, and entirely new fueling procedures. The Air Force may have been quietly building these systems behind the scenes. If the military creates a robust hydrogen infrastructure, it could accelerate the adoption of hydrogen-powered transportation across the entire economy. Everything from trucks to ships to commercial aircraft could eventually shift toward hydrogen as a dominant fuel source. Public reaction to the announcement has been a mix of excitement, curiosity, and skepticism. Many people are fascinated by the possibility of a cleaner and more efficient future for aviation. Others question whether this announcement is part of a strategic message meant to project technological superiority. Throughout history, militaries have sometimes revealed breakthroughs as a way to deter adversaries or reassure allies. Whether this engine is fully ready or still in early testing stages remains to be seen, but the impact of simply revealing its existence has already been felt worldwide. Scientists are eager to learn more about the thermodynamics behind the engine. Hydrogen burns faster and hotter than traditional fuels, which means the engine must be built from advanced materials capable of withstanding intense stress. There are rumors that the Air Force has been experimenting with new alloys, composite materials, and thermal shielding technologies that go far beyond what is used in current jet engines. If these rumors are true, we may be looking at an entirely new class of propulsion system that redefines what aircraft are capable of. There are also discussions about how this engine might influence space exploration. Hydrogen propulsion is already used in some rockets, and advancements made for aircraft could improve the efficiency and reusability of orbital vehicles. Some experts believe that the line between aircraft and spacecraft may become increasingly blurred as hydrogen technologies advance. Future jets might fly to the edge of space, reduce travel times across the world, or even enable rapid global strike capabilities that nearly eliminate reaction delays during emergencies. One of the most intriguing aspects of this development is how it fits into the broader pattern of technological leaps happening over the past decade. From autonomous drones to hypersonic weapons to artificial intelligence systems guiding complex missions, the Air Force has been steadily modernizing its capabilities. The hydrogen jet engine feels like the next major milestone in this trajectory. It signals a future in which aircraft are smarter, faster, cleaner, and more sustainable, while also offering overwhelming strategic advantages. However, challenges still remain. Even with a working engine, integrating hydrogen propulsion into existing aircraft could be complicated. Military jets are packed with electronics, sensors, weapons, and structural components designed around traditional engines. Engineers may need to redesign entire aircraft from the ground up to fully take advantage of hydrogen's unique properties. This would require time, funding, and extensive research. The Air Force seems confident, but many in the aerospace industry believe the transition will not be easy. The conversation is also shifting to how other nations will respond. China, Russia, and several European countries have invested in alternative propulsion research, but none have publicly claimed a breakthrough on this scale. If the United States has taken the lead, it could spark a global race similar to the space race of the 20th century. International competition often accelerates innovation, and we may see rapid advancements in sustainable aviation across the world as nations try to keep up. Another important point being discussed is how this technology might influence commercial travel. Airlines are under increasing pressure to reduce emissions and fuel costs. A hydrogen-powered engine that reduces operating expenses while offering greater efficiency could revolutionize the entire commercial aviation industry. Flights may eventually become cheaper, quieter, and more environmentally friendly. This could also reshape the way airports operate, the way airlines manage fleets, and even how passengers experience air travel. Looking ahead, there is a sense that the Air Force's announcement is only the beginning. More details will emerge in the coming months, and each new revelation will clarify just how transformative this engine truly is. For now, the world is watching closely. Scientists want to analyze the data, engineers want to understand the mechanics, and governments want to understand the strategic implications. This moment could mark the beginning of a new era in aviation, one defined not by fossil fuels but by a cleaner and more powerful energy source that could reshape global transportation and defense strategies. As interest builds, additional questions begin to surface. How will this technology influence the global economy? What will it mean for countries that rely heavily on oil exports? How will it affect military alliances, energy policies, and environmental regulations? These questions highlight just how wide-ranging the implications are. A single breakthrough in propulsion technology has the potential to reshape multiple industries and geopolitical relationships simultaneously. Experts also point out that hydrogen production itself could see rapid innovation as a result of this development. Demand for hydrogen will increase dramatically if aviation begins to adopt it at scale. This could accelerate progress in green hydrogen production, renewable energy storage, and advanced electrolysis methods. Ultimately, the hydrogen economy could expand far beyond aviation, influencing transportation, manufacturing, and energy infrastructure worldwide. In the meantime, people remain fascinated by the mystery surrounding the engine's design. At the center of the discussion is how the Air Force managed to handle hydrogen's extremely low temperatures during storage and its highly reactive behavior during combustion. Engineers reportedly developed a new type of cooling system that maintains stability even under extreme conditions. If this subsystem is as advanced as rumors suggest, it could be just as important as the engine itself. There is also speculation about whether the Air Force collaborated with private aerospace companies to develop the engine. The modern era has seen increased partnerships between military agencies and private innovators, especially in fields like rocketry, drone technology, and artificial intelligence. Some analysts believe that this breakthrough may have resulted from a joint effort combining military secrecy with cutting-edge private innovation. The announcement also raises important ethical and strategic questions. If this technology becomes a dominant force in global aviation, who controls it? How will it be regulated? How will it be protected from misuse or adaptation by adversaries? These are critical concerns for military planners and policymakers who are now weighing the benefits of revealing such a powerful advancement. As more information emerges, one thing is clear: the world has entered a new chapter in aviation innovation. The hydrogen jet engine revealed by the U.S. Air Force represents not just a technological milestone, but a signal of what the future may look like. A future where aircraft fly cleaner, faster, and farther. A future where nations depend less on fossil fuels and more on renewable energy. A future where the boundaries of engineering are pushed even further. In the coming years, we will see whether this engine becomes the standard for next-generation aircraft or whether it remains a specialized tool for military use. Either way, the impact of this revelation will be felt across the aviation world for a long time. Scientists will study it, engineers will build on it, and nations will respond to it. As the story continues to unfold, we will keep watching the developments, analyzing the updates, and breaking down every new piece of information for you. The world is changing fast, and breakthroughs like these give us a glimpse of where technology is heading. Thank you for watching today's video, and stay tuned for more deep dives into the latest global developments.